will show you a quick sample of what it is. So we have a customer data service here, which deals with the customer's core data, so first name, last name, email address, and so on, and he has its database and its own API where the customer can change his data. And every time a change is made to the database, we publish it to a queue, and other services can consume this queue if they are interested in this data. For example, there's an invoice service which is responsible of generating the invoice in the end, and he just stores a copy of this data in his database. And maybe there's a checkout service which needs maybe the delivery address, and he stores this data as well in his own database. And at this point, that would just be some kind of data replication. But what we allow, and I don't know if you can read that well. So this is just a small portion from the customer topic. So we have a customer ID, we have a name, a loyalty ID, an invoice address, and a delivery address. And the invoice service is just interested in the invoice address and in the name, so we can write a proper invoice. And the checkout service isn't interested in the invoice address, but in the delivery address, so it stores just that. So it's kind of an intelligent data replication. So what we mean by eventing is not messaging, because an event is always something that happens in the past. So this is a true fact, and there's nothing I tell anyone else to do. That would be a command, so event has already happened, and it's already persistent in the owner's database. And what is really important is that there's only just one service owning a topic. So just the customer data service is allowed to publish a customer topic. Otherwise it won't work. If there were two owning services, there would be chaos. And what's different here from event sourcing is that we always publish complete entities and not deltas. So if one customer makes an update, we provide a new version of this data record to the queue, and later we can delete the first one because there's no information in there that we need, and this is called log compaction in Kafka. And so what we cannot do is go back in time to a certain point in time and get this state back. So all the states before are lost, and we have just the latest state. This is a little bit simpler than doing the full event sourcing stuff. And what's really nice is you can do rewriting and rereading. So if one service adds a new piece of data, he can just republish all the entities, and the other services can decide, oh, okay, that's interesting for me, I need this piece of data, so I reread everything from the very beginning. So he just sets his offset to 0, and then he can consume everything again. So there's some lessons with the API we learned. One thing is that eventing is an API as well, just as the REST API, and they even look pretty much the same. Then we learned writing APIs is really hard. It should be easy, but what teams do, they tend to build APIs fitting to a special client. So in our case, it's the first client is the mobile app, and some of the APIs the backend teams did was they were pretty much fitting for this case, and when the second client came along, it didn't fit anymore, and we had to build changes in the APIs. So that's really hard, and it's a really hard process for teams to build generic APIs and not just one fitting for one client. And another thing is breaking changes, and this is really hard. We tell teams to not have breaking changes at all, but when they have to, they must behave exactly like this. For example, you have a resource and 2 clients there, and they are consuming this API. And then the team providing the resource has to do a breaking change. So what we have to do is they need to go to the teams providing the clients, and they need to ask them to please move to the other API. And when that's done, when in this case both clients have moved, they can get rid of the first API. That's easy if we have 2 clients, but imagine there are 30 or 50 clients consuming the API, then it's really hard to get them all moving to the new API. So this can be a process of weeks and months. So we ask teams to please avoid breaking changes.
So the last question is, how do you access such a microservice infrastructure? When you grow your service world up to 180, 200 services, you have a few problems to find the right service to answer the request, and you don't want to do special things in every service again. So this is the place where we generalize some things, and where we want to make it easy for the developers to provide their services. So what we do is we use gateways to enter our infrastructure, and we mainly have 3 gateways there. So the first one is we have in our shops, in those 15,000 shops, we have terminals deployed, and those terminals can offer receipt data, so you can get recipes there and then go shopping for this or that recipe. So, and this is connected to our infrastructure through such a gateway. We have, of course, web clients running there, which are using our shop, and there's the mobile app, which is handled by a separated mobile gateway. All those gateways do at least three things for the services. They are able to route the request to the right service. They are able to do authentication, so not every service has to handle authentication stuff and security stuff, but the gateways will handle this once and provide information for the services which the services can rely on. And the last one is, which we also have in all 3 ways, is composing requests, and this would mean in the mobile world that we want to spare requests for the mobile app, and we want to aggregate requests. So this would be one kind of composure, and in the UI world, which is, from my perspective, the most interesting thing, we want to get one web page from 100 microservices. And this is something where we didn't find a solution outside in the market. There are big companies doing this on the client side, so you have something like BigPipe where you can compose a page, but it's always working on the client side, and we wanted a solution for the server side. So what you see here is one of our product detail pages, or an example page. It is still in German, so don't care about this. And we have the search bar on the top. We have on the very top right the basket button where a flyout can pop out and show your current basket. We have a navigation bar, and we have, of course, the product details. And inside the product details, we have the Add to Basket button again. And this is coming from different services in our infrastructure. So you see there's a search team, navigation team, basket, header, and product detail team. And those teams are providing information for this page. And they are not only providing information, but they are providing real HTML snippets. They're providing real CSS and real JavaScript to build this page together. We had a few constraints to build this, and to build this UI gateway. And what we want to avoid is to have a special front-end team above all our vertical teams. We don't want to have a horizontal team, again, which builds only the front end and which everyone else relies on. So this would break everything and make everything worse. As Sebastian said, we cannot avoid this in mobile, but we try to avoid it where we can. The services should not only deliver HTML, so then we could have used something like edge site includes or so, but we want them also to deliver CSS, JavaScript, and everything they need. Of course, as we're running an e-commerce site, A/B testing should be possible inside the service. So we want to have the customer entering the page. There's a service which can decide which HB test group this customer belongs to, and this information is provided to every service, so every service can react accordingly to the A/B test. And we want to have the authentication and request enhancement handled in the gateway component, so not every service has to request more information, and not every service has to take care about special things like authentication. We want to do this once, but at this place we want to do it very good. And if you have it in 100 services, I would say there's a much bigger attack surface So would be more risky from our point of view. So what we came up with is something we call dynamic UI composition, and it solves those problems. When you go through it, you see there is the request coming from the web browser, entering this gateway component, we call it DUC, and the first thing happens here is that the request is authenticated at the authentication service, and this is the first information which is put inside an HTTP header, and spread to all other services which follow in this line. The next thing is that this component realizes, okay, you want to have a product detail page for a special product, so it has a configuration which says, okay, the root shows me it's a product detail service which is responsible for this page. It starts getting, later on. So point 4 is translate the session. So we have the customer information in there. We know which customer it is. We determine the test groups I said before, and then at 6, the product detail service, microservice A in this picture, is asked about the overall template of the page. And when we go back, this would be the very outer box we draw here. It would include everything the product detail service already knows, so the product picture, the product details, product description would be in there, but there would be also includes in there, special HTML text which shows this gateway component there's more to do. So, and what happens then, the template gets back, and in 7 on the left side, the includes are resolved. This is something which happens in parallel and can be recursive. So there can be includes and includes. And when all includes are available, those includes are placed inside the HTML page. The CSS is moved on the very top of the page in the order the includes appear. JavaScript is moved to the bottom of the page, and then we have a complete web page again, which can be delivered to the customer. I'd say inside this infrastructure, this is one of the more sophisticated things we build there, and definitely worth an own talk. But if you have questions about this, we are around. And for this talk, we only have a rough overview about this. And we are 10 minutes